In this video, we're going to be talking about OLS regression, or ordinary least squares regression. We're going to talk about this as a simple bivariate regression, meaning a relationship between two variables. So a bivariate linear regression basically finds the line of best fit for a set of data. So it takes the data and plots it on an XY axis, and then finds the line that best matches that data. This allows us to evaluate the association between two numerical variables. Now, we oftentimes do this with ordinal variables as well, as long as there are more than 5 categories, but it is ideal for variables that are numerical. You wouldn't want to use nominal level variables in a regression. There are other types of regression that you can use for nominal level variables. So the first step in regression analysis is to create that visual representation of the relationship between the independent and dependent variable, known as a scatter plot. So we're going to plot our x and y points along an x and y axis to see what that relationship looks like. So we're going to show an example in the next slide. So here we have our example. We're looking at education and hours spent on the internet. So we have education in terms of years of education, and then we have hours spent online. So that's what the www hours, hours spent on the internet. So here we have those. So what we want to do is we want to construct a scatter plot with this data. And so in order to do that, we need to identify which is the independent and which is the dependent variable. Now, education is going to be our independent variable. We're going to say that education has an impact or an effect on hours spent on the internet. So our independent variable is education, which means that education is going to be our x, and our dependent variable, hours spent watching television, is going to be our y. And so that's how we're going to set up our table. Now, a simple hypothesis for this might be that as education increases, hours spent on the internet also increases. And that could be a possible hypothesis for this relationship. So let's go ahead and plot these on an XY axis. Here we have an axis, and down here this would be our x, or our education. And then along our y-axis, we have our internet hours. So we can take each of our data points and plot those. So if you'll recall, the first data point has 12 years of education, so somewhere right around here, and 5 hours a day spent watching TV. And we need to mark this. So this is going to be, there's going to be 10 on here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. We'll mark that so that we know. So 12 years of education and 5 hours spent on the internet. So that's going to be our little dot. And that represents person 1. Person 2 spent 15 years of education and has 10 hours, spends 10 hours on the internet each day. I think it's each day, might be each week. So we go to the 15, and then we go up to the top to our 10, and we plot that point there. Then the next person has 10 years of education and 0 hours online, and so that person is down here. Then our next person has 13 years of education, so probably right around there, and 7 hours online on the internet. So that's 5, 6, probably somewhere right there. Okay, and then our last person has 12 years of education and 6 hours. So that person is going to be right there. So here is our we have 10 hours, so it's not perfect because, I'm doing it by hand. But we can see a trend. So we can see that there seems to be some sort of relationship. If I were to draw a line through this, it would probably look something, I'm guessing, like this. because we've got to account for this guy down here. But there's some sort of positive linear relationship. The more hours more years of education you have, the more hours you tend to spend online. So the way that we would interpret that is we would simply say that. It would appear that there's a positive linear association between one's education level and the amount of time they spend on the internet. In other words, the more years of education one has, the more time they are likely to spend on the internet. And so we're just simply describing what we see and what the overall trend is. So how do we know if that's correct? Well, we would go ahead and calculate the equation for that line, for the line. So the line of best fit is represented by this equation that hopefully looks a little bit familiar to you from your basic algebra days or quantitative reasoning. But you have your y, which is your dependent variable that we're predicting, and that equals a, which is what we call the y-intercept, plus b, which is the slope of the line, times x, which is the value of our independent variable. So our equation is basically the equation for a line. When I was in elementary school or high school, I learned this as mx plus b. So it's slightly different, but pretty much the same exact equation. So we're going to calculate, we need to figure out b and we need to figure out a in this equation. And once we have those, we can actually start to make predictions about what we think y will be given a particular x. So let's go ahead and start with calculating b. The calculation for b, or the slope of the line, looks like this. It looks complicated, but really it's not as complicated as some of our other equations that we've looked at this semester. So first, we have the sum of x times y. So we're going to take each x and multiply it by its corresponding y, and then we're going to add those up. Then we subtract the n, total number of respondents, times the mean of x times the mean of y. Then we divide all of that by the sum of the x squareds. So we're going to take each x, square it, and then add them together. And then we'll subtract n, the total number of respondents, times the mean of x squared. So we are going to create another fancy dancy table. And so our table is going to look like this. So here's our data put into the table. So our table is going to have columns for x, y, x times y, and then x squared. And that's going to be able to give us all the data that we need for our equation for b. So I've simply copied over the x's and the y's, again making sure to keep those in the same order and keep them paired up. Then I've just multiplied across to get my xy's. So 12 times 5 is 60. 15 times 10 is 150, 10 times 0 is 0, 13 times 7 is 91, and 12 times 6 is 72. Then I have my x squares, so I take the numbers in this column and I square them, which gives me 144, 225, 100, 169, and 144. Now for my equation, I have the sum of xy minus n times the mean of x times the mean of y. So I need to add up everything in my xy column, and that's going to give me 373. That's my sum of the xy. Then in that equation, I also need the mean of x and the mean of y. So I'm going to add up my x's and divide by n to get the mean. So 62 divided by 5 is 12.4. Then I need the mean of y. So again, I add up everything that's in the y column, which is 28, divide by 5, and that equals 5.6. Then on the bottom of my equation, I have the sum of x squared minus n times the mean of x squared. So I have the sum of the x squareds, which is 782, and then I already have my mean, and so I'll be able to plug that into the equation. So my equation for b is the sum of the xy minus n times the mean of x times the mean of y. And that is all divided by the sum of the x squareds minus n times the mean of x squared. So I can take what I learned from my previous slide and I can plug those in here. So my sum of xy is 373. Let's see, 373 minus, and n is 5, and the mean of x is 12.4 times the mean of y, which is 5.6. And all of that is going to be divided by the sum of the x squareds, which is 782, minus n, which is 5, times the mean of x squared, so 12.4 squared. So that's going to give me 373 minus 347.2. So that 347.2 is just 5 times 12.4 times 5.6, divided by 782 minus 768.8. And so you're going to have 25.8 divided by 13.2. And that's going to give us 1.95. Now, the b value can be any number from negative infinity to positive infinity. And we'll talk about how to interpret that in a minute. But this number can be anything. Now that we have our value of b, we also need to solve for our value of a so that we can make predictions, so that we have the complete line of best fit. So this is our equation for a. We have the mean of the y minus b, which we just calculated, times the mean of the x. And that's going to give us a. So we just need to plug in the numbers that we already know. So a is going to equal the mean of y, which is 5.6, minus b that we just calculated, 1.95, times the mean of x, which is 12.4. And so that is going to give us 5.6 minus 24.18. So again, make sure that you're going to two decimal places in all of this. And so we get negative 19.02. So the y-intercept can be a negative. It doesn't always make logical sense, but it can happen. So our full equation for the line then is going to be y equals negative 19.02 plus 1.95x. So if I gave you a number of years that someone has been to school, and I ask you to tell me or predict how many hours they are on the internet every week, you could do that by plugging that number into the x. So I can give you any x and we can predict y. And that's the beauty of the regression. So how would I interpret this? I would focus on the b value. I would focus on my slope. And so let's go ahead and look at that interpretation. So what I would say for my interpretation is that for every one additional year of education, we predict a 1.95 increase in the number of hours one spends on the internet. So basically, the slope of the line is this kind of little piece here. So we're predicting, this is the slope. So we're predicting that for every move this direction, every 1 unit, we will move up b units, or down, depending on if it's positive or negative. And so for our interpretation, for every 1 additional x, we predict a b increase in y. So that's going to be in your interpretation. You don't really need to interpret the y-intercept. You can put it in there, but mostly we're just looking at the slope and how much of an effect does the independent variable have on the dependent variable. So that's your regression line and how to interpret, and that concludes this semester of sociology statistics.